Hi, everybody. Today we're on Unit 8, Lesson 2, and we're going to be dealing with trig functions values using reference angles. I just hope you had a chance to practice some of the stuff we talked about yesterday, which was the concept of radian measure, how we can convert back and forth between radian and degree measure, taking a look at how to set up some function values of the quadrant angles, and using SOHCAHTOA to set up trig function values of what we call our special angles. Okay, so real quick, just to start today, let's draw and fill in the side lengths for each special triangle. So if I have a 45, 45, 90 triangle, these two angles are the same, both 45 degrees. Okay, you should know, without too much hesitation, how to put your side lengths on. Okay. Rad 2, rad 2, 2. If you have to set up a 30, 60, 90 right triangle, this would be my 30 degree, this would be my 60 degree. The side length across from the 30 is 1. 2 is the hypotenuse, and then radical 3 is across from the 60-degree angle. Okay, so these you have to memorize. Okay. How to use them is pretty easy once you have them memorized. So we're going to extend this concept today to set up trig function values that are greater than 90 degrees. Okay. So all of the angles we worked with yesterday were in between 0 and 90. Now, what happens when we go past 90 degrees and we go out into other quadrants? Okay, and that's what we're going to be dealing with. So in order to do this, we use what we call reference angles. To remember where each trig ratio is positive, remember the phrase, all students take calculus. Okay, let's talk about this for one moment. So here's our XY axis. We have 0 degrees, 90 degrees, which we know is equivalent to pi over 2 in radian measure. 180 degrees, which we know is equivalent to pi in radian measure. 270, which we know is equivalent to 3 pi over 2. Okay, so you should kind of have a reference. These, again, we consider our quadrant angles. Now, depending on, we always start on the x-axis, depending where we open up to, we're going to land in different quadrants. If our angle is in between 0 and 90, that's quadrant 1. If our angle is in between 90 and 180, that's quadrant 2. 180 and 270, that would be quadrant 3. 270 to 360, or 2 pi, that's going to be quadrant 4. So there's our angle measure as an acute angle. Now, how do we find that angle measure, right? So let's say, for instance, I open up an angle to some random, first quadrant angle or acute angle. Let's say I have the value of that angle, right? So I open up an angle. If I drop a perpendicular down, okay, this angle, theta, is in quadrant 2. We can use this angle to set up trig function values, but we need to find out what angle it corresponds to. The way we do that is 180 minus theta. When we have our angle in quadrant 3, drop a perpendicular to the x-axis. Okay, so we can use the side lengths of that triangle, and to find the reference angle for that angle, remember, that's that guy there. That's the triangle we're using. We do theta minus 180, because it would be the angle that we're given, subtract out theta. That's going to give, the big angle. Subtract out 180, and that's going to give us the reference angle that's left. And in the fourth quadrant, if we drop a perpendicular to the x-axis, we're going to find the value of that angle, reference angle, by doing 360 minus theta. So that's really it. Okay. Now, how do we know if a sign is positive or negative? Well, here's the thing. Let's go up here for a minute. In the first quadrant, we know our x value is positive and our y value is positive. In the second quadrant, we know our x value is negative, but our y value is positive. I don't know if this is too sloppy. In our third quadrant, both x and y are negative. And in the fourth quadrant, our x value is positive, but our y value is negative. Now recall what we said about the unit circle. In a unit circle, the cosine corresponds to the x value and the sine corresponds to the y value. So in the first quadrant, when both are positive, that means everything is positive. All of our trig function values will be positive. In the second quadrant, the cosine is negative and the sine is positive. So the sine is positive, the cosine is negative. And if the cosine is negative and tangent is sine over cosine, that means the tangent is going to be negative as well. In the third quadrant, both x and y are negative. So this is where the tangent is positive and the sine and cosine are both negative. And in the fourth quadrant, the cosine is positive and the sine is negative. So the cosine is positive. So really, if you learn how to use this chart and set up your reference angle properly, you will be very successful with setting up trig function values that are larger than 90 degrees. Okay. And reminder, all students take calculus is our helpful saying that reminds us what quadrants we're positive in. To be able to calculate the exact value of angles larger than 90, we're going to find the reference angle. The reference angle is always an angle between the terminal side and the x-axis. The reference angle will always be an acute angle, but depending on the quadrant, we're going to change the reference angle and it may affect the sign of your ratio. So in simplest terms, my recommendations to you, we find the value of the reference angle. We set up a ratio and adjust the sign. And if you can remember this little set of rules here, you're going to be really good. So we're going to find the exact trig function value for each of these. Okay. So we have to find the reference angle. We want to set up the function value for the sine of 210 degrees. Find the reference angle. Okay, so I think in my head, 210 degrees, what quadrant would that be in? Well, it's an angle between 180 and 270. So to find that reference angle, I use this, right? So I think in my head, 210 would be somewhere over there. 180, 270. So I'm going to use the rule. So 210 minus 180 gives me 30. So I'm really setting up the function value for the sine of 30 in quadrant 3. First thing is I do is I think about my triangle. I'm just going to draw them down here. 30, 60, 90, 1, 2, rad 3. I just draw them when I need them. Sine of 30 is 1/2. Adjust my sign. The sign is negative in the third quadrant. And there you have it. That's how we set up a function value. The cosine of 210, once again, 210 would be in between 180 and 270. That gives you the quadrant. The quadrant will give you the rule and the sign. We know from the previous example, it would be 30 degrees. The cosine of 30 is radical 3 over 2. And in the third quadrant, the cosine is negative. And there's your answer. Tangent of 11 pi over 6. Oh, I'm jumping to a difficult one right away. So the tangent of 11 pi over 6, now we want to think about this. My brain doesn't work in radians. I'm going to convert this 11 times 180 divided by 6. Well, 180 divided by 6 is 30. 11 times 30 is 330. So it's the same as setting up a function value for the tangent of 30. Now we have to think about, where does 330 land? Well, 330 is in between 270 and 360. So we're really setting up the trig function value for that angle, right? Remember, these are coterminal. They kind of are the same angle. So we're going to use the tangent of 30. Tan of 30 is opposite over adjacent. So the tan of 30 is radical 3 over 3. And in the fourth quadrant, the tangent is negative. The tangent is negative because the cosine is the only angle that's positive in that quadrant. So the tan and the sine will be negative. And in our last example, cosecant of 5 pi over 4, well, this is not our last example, sorry. In our next example, cosecant of 5 pi over 4 is cosecant of pi over 4 is going to be 5 times 45. I'm sorry. I'm jumping ahead of myself here. 180 divided by 4. Well, 180 divided by 4 is 45, right? So 5 times 45 is 225. So the cosecant of 5 pi over 4 is equivalent to the cosecant of 225 degrees. 225 degrees is a third quadrant angle. So I'm going to do 225 minus 180 to get the value of this piece here, this reference angle, right? And so we're finding we're going to set up the cosecant of 45 degrees in quadrant 3. Well, the cosecant of 45 is the same as the sine of 45, but flip it. The sine of 45 is rad 2 over 2. I'm going to flip it. I get 2 over rad 2. Rationalize it. I'm going to get 2 rad 2 over 2. That's going to cancel. So the ratio is just radical 2. Now we're going to say, what's the sine? Well, in the sine, all students take calculus, right? All students take calculus. The sine is going to do whatever the cosecant is going to do whatever the sine does. So since the sine is negative, the cosecant is negative as well. In example 5, remember, whatever operation we can already do in math, we can do with trig function values. Sometimes the numbers might not be so nice. We're going to use exact values, no radicals in the denominator. Cosine of 45 rad 2 over 2 minus the sine of 270. Now here's where you have to recognize 270 is a quadrant angle. 270 is here. It's the point 0, negative 1. So the sine is going to be the y value. The sine, so radical 2 over 2 minus negative 1. We get radical 2 over 2 plus 1. We really should combine this and make this one ratio, because remember, technically it's our end answer has to be one fraction. So radical 2 over 2 plus, when I want to add this together, 2 over 2 equals rad 2 plus 2 all over 2. And that would be your final answer for that one. Now we're going to get a tiny little bit more complicated here. Okay. So I see some multiple pieces. The first thing I want to concern myself was converting this radian measure. So I have 5 times 180 divided by 4. 2 times the sine. 180 divided by 4 is 45. Notice how easy it is to do if you do it this way. So this is really 5 times 45. I can do this in my head. Plus 3 times 180 divided by 4. 3 times 45. 3 times the tangent of 3 times 45 is 135. Now all I have to do is find each reference angle. 225 is in quadrant 3. So this is going to be 225 minus 180. 2 times the sine of 45 degrees in quadrant 3. Plus 3 tangent of 135. 135 is a quadrant 2 angle. 180 minus 135 is 3 times the tangent of 45 in quadrant 2. What is the sine of 45? Rad 2 over 2. What is the sine, SIGN, of the sine function in quadrant 2? Well, that's positive, so I leave it alone. Plus 3. Oops. Sorry, I'm on this side. Just saw that. We're setting up this guy. 225 is in quadrant 3, so we're going to negate it. Sometimes it's good to make mistakes. Keeps you careful. Tangent of 45. Tangent of 45 in quadrant 2. This one is the quadrant 2 angle. So the tangent of 45, I just draw my triangle whenever I need it. The tangent is opposite over adjacent. So the tangent is 1. And in the second quadrant, the tangent is negative. So we're there. Now we've got to do our math. The 2's cancel. Negative radical 2 minus 3. And that is your final answer. Little bit of work with these ones. Okay, you're going to make sure you know how to set up basic, and then you have to also know how to do the operations. Sine of negative 135. Okay, now let's talk about this. The sine of negative 135, we could do one of, a couple different ways. But basically, when we open up in the negative direction, we're opening up here. Some of you may find it easier to adjust your angle. And we know we can do negative 135 plus 360. So if you do negative 135 plus 360, we're really opening up 225 degrees in that direction. Okay, so negative 135 is the same as opening up an angle as 225. Okay, so if it's easier for you to adjust the angle first, that's fine. In a second, I'm going to show you a different method. Okay, so now we would find the reference angle, 225 minus 180. We're setting up the sine of a 45-degree angle in quadrant 3. Ratio, adjust the sine. Now, another example, another method we could use, instead of adjusting our angle before we find the reference angle, sometimes when we're dealing with some calculus problem, it's easier just to use the even and odd properties of trig functions when setting up our function values. Remember, a function is even if f of negative x equals f of x, or it's symmetric with respect to the y-axis. A function is odd if f of negative x equals the negation of f of x. Easier to see the picture if it's symmetric with respect to the origin. Now, last year, you studied the sine and cosine curve. So I'm just going to kind of, we're going to study it in more detail tomorrow, but jump in here. It's easier to determine whether a function is even or odd by looking at a picture. So let's think about this. When I look at this sine curve, right? And remember, the sine curve kind of goes out in different, it's oscillating and it repeats itself. Is this function symmetric with respect to the y-axis, or is it symmetric with respect to the origin? Hopefully you see it's symmetric with respect to the origin, so we can say a sine function is an even function. In terms of what this lets us do mathematically, we could say that the sine of negative theta equals the negation of the sine of theta. Basically, that's what it lets us do. And that's the easiest way to remember it. Even, duh, would help if your teacher used the right words. I said the opposite of what I wanted to say. This is an odd function, right? And with an odd function, the sine of the negative input equals the negation of that function. When we look at the cosine function, this one's very easy to see. I should have done the cosine first. The cosine function is symmetric with respect to the y-axis. So the cosine function is what we call an even function. And we know with an even function, f of negative x is the same as the original function itself. That's how we would write the property. And the tangent function, and I know you guys did not study the tangent function that much last year, but our tangent function, if we sketched it, would look like this. And you can clearly see that the tangent function is also symmetric with respect to the origin. So the tangent function is what we consider an odd function as well. So the tan of negative theta equals the negation of the tan of theta. That's how we represent it with the function notation. Now, I'm not going to really make you use these if you don't like to, but I'm showing them to you because they may come up next year. So if we want to use even and odd properties to find exact trig function values, just remember the sine of negative 45, instead of adjusting it, you could just take that negative out front. And that's negative radical 2/2. So it makes analyzing things a tad quicker if you memorize your properties. The cosine of negative pi, well, when it's a cosine angle, it doesn't matter. It's the same as the cosine of pi. It's kind of easy to see with this one, by the way. And the cosine of pi, if you think about it, cosine of pi, -1, 0. So the cosine is -1. Just real quickly, the cosine of negative pi is the same as the cosine of pi. Okay. It's really kind of easy to see that one. Cotangent of -3 pi/2. Well, our reciprocal functions are going to work the same way, except we have to remember that we need to kind of flip whatever we get. Okay, so when we're thinking, so the cotan of negative 3 pi over 2, sorry, is going to be the same as the negative cotan of 3 pi over 2. So 3 pi over 2 is 0, negative 1. Tangent is sine over cosine. So cotan is going to be cosine over sine. So negative 0 is just going to be 0. Again, I'm giving you just an alternative way to analyze these negative angles. If you don't love them, don't use them. Okay, because if you think about this, cotan of negative 3 pi over 2, if you really know what you're doing, cotan of negative 3 pi over 2, right, is the same as the cotan of a 90-degree angle. And if you set that up, you're going to get the same answer. Okay. So again, our aim here is just to give you alternate ways to evaluate things, especially if it's going to help you in the future. Okay. Thank you so much, guys. I appreciate you coming here today, and see you again soon.